Assalamu alaikum wa rahmatullah. Hi everyone. This is the last video for question 4-5. We are at question 15. We have this region bounded by f and g. Question 15 says, let h be the function given by h of x equals kx times 1 minus x for each k is positive, bigger than 0. The region, not shown, sorry, enclosed by the graphs of h and g is the base of a solid whose cross sections perpendicular to the x-axis are square cross sections. There is a value of k for which the volume of this solid is equal to 15. So we are given the volume to be what? To be 15. Right, but do not solve an equation involving an integral expression that could be used to find the value of k. So we know that the volume runs from 0 to 1. Okay, it runs from 0 to 1 of h of x, which is it's kx, right, bracket 1 minus x, okay, minus 3 bracket x minus 1 root of x. Okay, this is all square because the cross sections are squares. Equals to what? The volume equals to 15. So if you solve this equation, you get the value of k. But we don't need to solve for k. So question 16 says, let R be the region bounded by the y-axis and the graphs of x cubed over 1 plus x squared and 4 minus 2x, as shown in the figure above. The region of this base, the region R, is the base of a solid. Each cross section perpendicular to the x-axis are squares. So we are integrating from 0 to which value? We don't know, right? We are integrating from 0 to this number, right? So to find this value, you set the two functions equal to each other. X cubed over 1 plus x squared equals 4 minus 2x. You will get x equals 1.48766. So this is the value of the x. Now the volume is given by the integral from 0 to 1.48766 of the upper one, which is the linear, which is 4 minus 2x, minus the lower one, which is x cubed over 1 plus x squared. This is all squared dx. Use your calculator to solve. 8.997. This is the volume of this solid. So, moving on to question 17. Question 17. We have this region bounded by the functions. Okay. So before we start doing A, B, C, and D, let's put all the givens on the graph. This one is ln of x plus 3. Okay? And the bottom one is x cubed plus 2x squared. This point here is minus 2 and 0, right? And this point here, we don't know what this point is, so let's name it what? B and C. I didn't use A and B. Instead, I used B and C because it says they meet at x equals 2 and at x equals b. So I named the x coordinate b. Now, if you find the intersection point using the graphing calculator, it will be 0.78198, comma 1.33025. So I will be referring for the first number with B and the second number with C. Okay? Find the area of the region enclosed by the two graphs. Let's start doing now the question. The first part, to find the area, you will find the area from the integral from -2 all the way to b, okay, which is the x value we just found, of the upper, which is ln of x plus 3, minus the lower function, it's x raised to 4 plus 2x raised to 3 dx. It's a calculator active question. We can evaluate it using the calculator. 3.604. This is part A. Now part B says for x goes from -2 to b, okay, let h of x be the vertical distance between the graphs of f and g. So h of x is the vertical distance between what? Between f of x and g of x minus g of x, right? It says, is h increasing or decreasing at x equals -0.5? Give a reason for your answer. So we are looking at h prime of -0.5, h prime of -0.5, which we can do it like this. What is the f? F is ln of x plus 3 minus x to the power of 4 plus 2x cubed. Okay, this is at x equals -0.5. Okay, we must get -0.6, and because this is h prime of -0.5, how do we justify now our answer? We will say that this is less than 0, it's negative. That means the answer is this, h is decreasing at x equals -0.5, because it's negative, right? Okay. Part C says the region enclosed by the graphs of, let me give myself a space, says the region enclosed by the graphs of f and g is the base of a solid, cross sections of the solid taken perpendicular to the x-axis, and they are squares. What does that mean? Well, find the volume of the solid. So the volume will be the integral from -2 all the way to b, right? From -2 all the way to b, of the upper one is f of x minus the lower one is g of x all squared dx. You can write what f of x is and what g of x is. For the sake of time, I'm just going to skip this part. It's equal to 5.340. The last part of this question, says a vertical line in the xy plane travels from left to right along the base of the solid described in part C. Now the vertical line is moving at a constant rate, right, of 7 units per second. يعني dx, because the vertical line is x equals something, so dx over dt equals 7 units per second. Find the rate of change of the area, which area of the cross sections above the vertical line. Above the vertical line with respect to time, when the vertical line is at position x equals negative 0.5. Well, let me highlight what we are looking for. We are looking for the rate of change of the cross sections with respect to time. With respect to time, that means we are looking for dA over dt. This is what we are looking for, dA over dt. Okay, now what can we do is this. We are looking for dA over dt. Okay, we can find dA over dx, and we will multiply it by dx over dt. Okay, because here if you cancel dx with dx, that leaves you with dA over dt. Okay, so we need to find dA over dx, okay. We need to find it at x equals negative 0.5, and we will multiply it by 7. Okay. Now, what is the area as a function of x? As a function of x, the area equals, we described it in the previous parts. It's f of x minus g of x, right? F of x minus g of x, all squared, right? All squared. Now, if you find a prime of negative 0.5, it will be negative 1.3245, right? So this value, I'm going to write it here, negative 1.3245, and then I will multiply it by dx over dt, which is 7. So what do we get? We get negative 9.2718 area, which is unit squared per second. Okay, so this is part D. The last part question in this file is this one. We have a region R enclosed by those two functions. Okay, the cross sections are squares, they are perpendicular to the x-axis. So we are going from 0 all the way to this number, which is not 1, but we need to find it. Okay, so if you set the two functions equal to each other, okay, you will get x equals 0.94194. Now to find the volume, you will integrate from 0 to 0.94194 of the upper, which is e to the power of minus x squared, minus the lower one, which is 1 minus cos of x, all squared dx, and this is equal to 0.461. This is the last question. I hope this question and as well as the previous questions were clear. I wish you all the best, everyone.